and what that will entail. So this is 8.2 similar polygons. We'll get this started. So their picture. So how they're kind of describing it is, you know how like if you've ever like had a phone, like a picture on your phone, and you've like scaled it, like you like made it smaller or bigger to fit in a certain window. That's in a way making it a different ratio or a different proportion. So that's how they said their little picture for this. And then we've got our one standard for today. And then we're just going to do one of these words, and I'll read it a couple times. We're going to write down the definition for similar polygons. And remember, a polygon is just any kind of shape that doesn't have a curved part to it. So like a circle wouldn't be a polygon. Okay, so here's our definition. Two figures are similar polygons if one can be obtained from the other by a dilation or a dilation with one or more rigid motions. Okay, I'm going to read that again. Similar polygons. Two figures are similar polygons if one can be obtained from the other by a dilation or a dilation with one or more rigid motions. So what that means is it's a shape that's either been blown up a little bit, so it's an enlargement, or it's shrunk down a little bit, so it's a reduction. So it takes the same size and then makes it bigger or smaller. So it's like a triangle that's grown or gotten smaller. And then it could also be the rigid motions are like our slides and our rotations. So not only might it get bigger or smaller, but it might slide or it might rotate. And so we've got those similar polygons. And we'll see that today. That's what we're focusing on, is to really get this down. All right, so now to see a picture of this, here would be a picture of similar polygons. So it's the exact same shape, but it's just gotten smaller. So that would be a reduction. So here's this shape. It's a quadrilateral, A, B, C, D, and then it's been reduced into W, X, Y, Z. So same shape, just a different size. That's what a similar polygon is. Now, the math that's going to go behind this, if we look at these two shapes, is side AB the same length as side WX? No, they're going to be different lengths. But all of the angles are going to match between the shapes. So angle A will be as big as angle W. B and X will match. D and Z. C and Y. So all of the angles will be equal. The sides are going to be different, and here's where the fraction comes in. The sides are going to be what we say are in proportion. So every set of sides is going to have the same scale factor. So for instance, if this were 10 and this were 5, it's been cut in half. So then if this is 6, this would have to be 3. The proportion will have to match between the sides. And that's, again, what we're going to practice today. But we're going to write that little tidbit in our notes. So here's the next thing for our notes. Corresponding angles are congruent corresponding sides are in proportion. And what that really means is the scale factors match. So angles will always equal. If angle A is 50 degrees, angle W is 50 degrees. And then we're going to set up fractions for our sides. Angles are equal, sides are going to have a fraction, a scale factor. And then we're going to see what an example will look like here in just a little bit. Okay, let's look at our example. This first example, I'm just going to have you follow along. I don't want you to write it yet. Just kind of watch, and then I'll give you one to try. So for this is kind of how some of our homework problems will work. In the top, it tells us that the shapes are similar. And I'm going to write that a little bit bigger so we can look at it. It says ABCD is similar, and this is new for us. The symbol for similar is just one little squiggle. And it's similar to PQRS. Then they're going to ask us to list all the things we know because of that. So we're going to say everything we know about their angles, and we're going to say everything we know about their sides. Now, do you remember when back in the day, this was when we did triangle proofs, when we said like 2 triangles were congruent, like triangle ABC was congruent to triangle DEF? Was the order that we said that important? Did the letters have to line up? Yes. Same thing here. So when they give you a similarity statement, they're actually helping you out to know what order you're looking at. And so since A is the beginning, it's going to match up with P, which is the beginning. So the order is there to help us. And you'll notice if you look at the picture, here's A, here's P. So they did a little rotation. And so the first thing we're going to do is we're going to list all of the angles that are equal to each other. Well, you can look at the picture, but you can also just look at the order of this statement. So I know angle A has to be congruent to angle P. Angle B, second letter, has to be congruent to angle Q. Angle C has to be congruent to angle R. And then last letters, angle D has to be congruent to angle S. So that's the first thing you'll do is you'll list all of the angles that are equal, and you can just go by the order that they're. Okay, now the second thing we need to do is we need to set up the fractions of the sides or the scale factors. So if I look at side AB right here, I have to say which side it also matches up with. Well, again, you can look at this order. AB, first 2, PQ. And what we do is we write it as a fraction. So AB and PQ are the sides that are similar. And if we had how long they were, then we put the numbers there. But right now we're just writing their fractions. Okay, now we've got to do another set of sides that are similar. So I could do BC. BC matches up with QR. So BC over QR. Those sides are in proportion. Then I want to do the third sides. CD is going to match up with RS. CD matches up with RS. And then the last set of sides, DA and SP. So what's different between this and when we did congruent triangles, these sides aren't equal to each other, they're in proportion, so we have to write them as a fraction. So the angle part will seem similar. Tell us that the angles are equal to each other, and then match up your sides between the triangles and make a fraction out of them. Now, if there were 5 sides to this shape, we would have 5 different fractions, and we would have 5 different angles. So that just depends on how many sides. So I'm going to give you one of these to try here in just a second. Before I erase this, is there anything up here that you want to ask about? Okay, I'm going to erase it and then show you one to try. Okay, so here are the triangles. It says triangle FGH is similar to triangle JKL. So I want you to list the angles that are equal. So there will be 3 angles that are equal. And then I want you to list the 3 fractions of the sides that match up in proportion. So we'll try that out and then we'll check them together. So the angles that are equal and the sides that are in proportion. Okay, let's start with angles, and I'm going to have you guys give me the angles that are equal. So somebody tell me one set of angles that we know have to be equal to each other. What's one of the 3? F and J. Both letters, and so I know angle F and angle J have to be equal. So that's one of the 3. Okay, who's got a second set of angles that we know have to be equal in that picture? G and K. Those are our middle letters. Okay, one more set. What's our last set of angles that we know have to be equal? H and L. Okay, so that's the first half of this, listing the angles that are equal. Okay, now we need to set the sides in proportion. So aside from the left triangle is going to match up with the side from the right triangle. Who's got one of the fractions for us of sides that are going to be in proportion? One set of sides between the left and the right triangle that we know match up. FG and JK. So what we do is we make one fraction out of that. FG over JK. Now you can look at the picture, but what's always a surefire way is, so see how FG is the first two letters? Match it up with the first two letters over here. Okay, we've got two more to go on this. What's another set of sides that are going to be in proportion from one triangle to the next? Go left to right. What's another set of sides? Yeah, so GH, second two letters. KL, second two letters. GH, KL. Okay, last set. The third set of sides from left to right that are in proportion. What are those going to be? There we go. So it was like first and third, FHJL. And that's how they would want us to answer that. It's just listing the things, the angles that are equal and the sides that match each other. Okay, do you have any questions for me on that one? Okay, the next type of question then, I'm going to use a word even though it's not the way that you think. We're going to prove whether shapes are similar, but it's not in the sense that we're doing a proof. We're just seeing if all the parts are there to know that the angles are equal. So I'm going to walk you through this one, and then I'm going to give you one to try. But in order to prove that it's a set of similar polygons, we have to be able to prove that all of the angles are equal, and then we have to prove that all of the sides are in proportion. Okay, so triangle ABC, we're trying to see if it's similar to triangle LMN. So we have to check to see if all of the angles are equal first. Okay, well, A and L. Can I tell by the picture that A and L are congruent angles? Yeah, they have one arc, so that means they're equal. Okay, next, B and M. Do I know that angle B and angle M are equal? Yeah. Okay, third, C and N. Okay, now they don't have any marks, but there was this little theorem back in chapter 5. And it said if two angles are equal, the third angles also have to be equal. It was called the third angles theorem. So if these two were equal to each other, then that means the third angles also have to be. So what we just proved is half of this. I know that angle A is congruent to angle L, angle B is congruent to angle M, and angle C is congruent to angle N. So I know that the angles are equal. Okay, the next part is going to be what's brand new for us, proving that the sides are in proportion. Okay, so now I'm going to set up the ratios and then we'll put the numbers in. AB has to match up with LN. BC has to match up with MN. And AC has to match up with LN. And so now I've got to put the numbers from the sides in there and see if all the fractions are indeed equal. So for AB over LM, that's going to be 3 over 2.25. Okay, then for BC over MN, 7 over 5.25. And then AC over LN is 6.75. Okay, so that is the numbers in. And then I have to see if these are equal. Well, right out of the gate, probably no one's going to know off the top of their head if those numbers are equal. But guess what? We have calculators. Grayson, you know? You don't know? Okay. Can I get 3 volunteers with a calculator? Who can be one of my volunteers? Ugh, one volunteer. And then who has a calculator? No one has a, Connor, I see the calculator. Connor, will you do 3 divided by 2.25 for me? Okay, thank you. 1.3 repeating. Anybody else have a calculator? Or are we going to ask Connor to do it again? Connor, will you do the second one for us? 7 divided by 5.25. Okay. And third, 9 divided by 6.275. Okay. I was like, I thought they were. Okay. So, thank you, Connor. Are all of those sides in proportion? Yes. Okay, what if that number had been 1.44? Then we would have said no, that they aren't similar. But if all of those fractions are equal, then we say that these are similar polygons. And so then we would say yes for this. So that's how we're going to prove it. We're going to check that all of the angles are equal, and then we're going to check that all of the sides match, and then we'll know yes or no. Okay, I'm going to give you one to try. So I'm going to erase. Anything you want to ask before I erase? Okay. Let me erase and show you one. Okay, so in this, triangle NQP is similar to triangle RST. Okay, so here's what I'm going to have you do. In your notes, write down if you know the angles are congruent, then set up your ratios of the sides and check them all to see if they give us the same number. So we'll check, I'll give you a few minutes. This one takes a little bit longer than the last one. Okay, you could still work if you need to, but I'm going to start talking about it. So first I've got to check the angles just to make sure the angles are equal. Do I know N and R are equal? Yeah, they both have one arc. Do I know that Q and S are equal? Yeah, they both have two arcs. And so because those two are equal, automatically I know that the third angles are equal. Okay, then for my ratios, side NQ is going to match up with RS. So we should have 12.5 over 10. QP is going to match up with ST. And then NP is going to match up with RT. So those would be the ones we check. What's 12.5 divided by 10? 1.25. What is 11.5 divided by 9.2? 1.25. What is 15 divided by 12? So are these two similar? Yeah, so that's how we're going to check that. That's how we prove that they're similar. Double check that their angles are all equal, and then set all their sides up in proportion and check that those numbers are. We can do that. That's fine. That's probably better than another kind of proof we can do. Okay, now the next thing I'm going to show you, we're going to get some algebra in the mix. We haven't done algebra problems in a while. And this is going to be kind of what will remind you of middle school math a little bit. So here, as we look at these shapes, they're like trapezoids. And the directions are telling us that they are similar. The sides are going to be in that put them in proportion, and then we're going to do something called cross multiply. Okay, so I see that this side WZ has a number on it, so I'm going to use WZ. I've got to figure out what side that's in proportion to. So when I look at this similarity statement, WZ is the first and fourth letter, so it has to match up with P and S. So that'll be one fraction. And then I see that I have something on ZY. So those are my last two letters. So it's going to match up with SR. So that tells me what sides match up based on what I have numbers on. Okay, then I'm going to put my numbers in there. So 16 over 12 equals 5y minus 2 over 6. So we figure out what sides are in proportion, and then we put their numbers. Okay, I'm going to have you write this down for me, and we're going to solve this together, just because I want us to be careful on some algebra stuff with this. So go ahead and write 16 over 12 equals 5y minus 2 over 6. Okay, now, the way that we're going to solve this is called cross multiply. But I realize every year that you guys come from different middle school teachers who all say this in different ways. Do any of you remember like solving things like with a butterfly method? Does that sound familiar to anybody? Because some teachers use butterfly. How about fish? A fish method? Does that sound familiar? Just cross multiply sound familiar to anybody? Okay, maybe they got away from the animals. But here's what we do when we solve fractions like this. I'm going to put this little cross, this little X in here, and we multiply across like this. So I'm going to multiply 16 times 6, and that actually gives us 96. And then I'm going to put an equal sign, and then I'm going to multiply 12 times that whole 5y minus 2. Okay, here's where people kind of make a mistake on this one. You've got to multiply 12 times all of this. And so that's why I wrote it like this, because we actually have to distribute that 12 through, or else we're going to get the wrong answer. So I'm going to have 96 equals, when I distribute the 12 through, it'll be 60y minus 24. I'm going to add 24 to each side and then divide by 60. And that'll give me my answer. So we cross multiply, we multiply across the x, but when there's multiple things, you have to remember to distribute or else it won't work out. Okay, so that would be our answer. We set up our proportion, cross multiply, and we get there. So here's our algebra return. Okay, let me give you one of these to try with some algebra. Okay, so here are the two shapes. Figure out what sides are going to match. Write a proportion. I'm going to just let you try it all on your own. And then we'll try to cross multiply. If you get stuck on something, let me know, but I'll do it together with us at the end. But we'll see how far we get on this one. I'm going to set up the proportion for you so you can check if you're that far along. They switch sides on you according to the similarity statement, so make sure you caught that. Okay, so just to double check on your proportion, side AF is 12. But if I look at the similarity statement, that's the first and the fourth letter. So it matches up with the first and the fourth letter. So it matches up with VZ. So that's why 12 and 3y minus 1 go together. And then 9 and 6. And then we cross multiply. So 12 times 6 is 72. And then it's going to be 9 times all of this. So that's when we're going to distribute. So then we'll have 72 equals 27y minus 9. I'm going to add 9 to each side. And then divide by 27. And that'll give us 3. So just be careful on how they might flip the picture. So always follow your similarity statement to know what sides go. And then the other thing is always do that distributing when there's more than one thing. So questions you have for me on the algebra part. Okay, there's one more type of question I need to show you today, and then we'll be done. And it's about perimeters. So I'll show you that one, and we'll practice that one together. The perimeters of a shape are also in proportion. So like if I added up all of these sides and added up all of these sides, I can make a fraction with that as well. So we're going to do just one of these. We're going to do it together. And it's going to be of this map. So this is the map at a mall. What we're going to do is we're just going to draw a rectangle. So we'll put this rectangle right here. In the directions, it's telling us how long each of the sides are. So I'm going to put the sides from the directions. I'm going to label it with the corners. So we'll draw this first. So this is the map, and it's going to be in proportion to like the real life mall. So like on the map, this might only be 2 inches and 3 inches, but in real life it's bigger, and that's what we're going to figure out. Okay, so here's what we need to find. First of all, they're going to tell us the perimeter of the mall in real life is, let me find it again. I think it's 30. Yeah, 30. So the perimeter of the mall in real life is 30. We are going to figure out how big side AD is in real life. Okay, so that's a little map, that blue rectangle, and we're going to figure out how big AD is in real life. Okay, so here's what we do. Side AD on the map is 2. In real life, we don't know how big it is. Equals, okay, now we're going to find the perimeter of the map. So if you look at that blue rectangle, we can figure out how many numbers it is around by just adding them. 2 plus 3 plus 2 plus 3. That's the perimeter of the map. In real life, the perimeter is 30. And then we're going to cross multiply. So 2 times 30 is 60 equals 10 times x. And then we're going to divide by 10. Divide by 10. And that's our real life number. So it's like how you can take a map. If you look carefully at any maps, they always have like a little scale factor. That's what we're doing right here. We're figuring out our scale factor. So it works for perimeters just like sides is all we needed to do. Okay, we're going to stop there for today. That's good for today. There's 8.2 homework for tonight. It's on